Hey everybody, and welcome back. Today, I'm going to be telling you about Crowdsec. I'm going to talk to you about what Crowdsec is, why you would want it, how it works, and I'll be covering all of the installation steps, including giving you the working configs in my GitHub. So let's get on to what Crowdsec is. The name pretty much spells it out. It's crowd-based security. So as I mentioned in my previous video with Sophos XG about how it has real-time threat detection and a real-time database that's updated by all users in the ecosystem, that's the exact same approach Crowdsec takes, except it's vendor agnostic, so it doesn't need a Sophos XG, it simply needs you to feed it some logs. In this case, we're going to be implementing it with Traffic Proxy, and it's going to be parsing all of the logs in Traffic to evaluate it against its known database of threats that are continuously updated by other users that report and contribute to its database. So why is that good? Well, exactly the same benefits as before. We're getting up-to-date security based upon real threats elsewhere in the world. Hopefully, that means that the same attack cannot happen twice because it would be caught. So how does Crowdsec work for Traffic? Well, it's pretty simple. We deploy Traffic, we're going to be doing that in Docker, and we deploy Crowdsec as another Docker container. Now, Crowdsec works in tandem with Traffic, and we need to feed it the logs. So you'll have noticed in the previous video when we set up Traffic that one of the volumes we specified were the traffic logs. Now Crowdsec is made from a few core components, and we can walk through their diagram to explain exactly what's happening here. So we have a number of log sources. These are things that we want to check for those indicators of compromise. These logs will be parsed by an agent, i.e. they'll just be simply scanned. And when you run these agents in Docker, if you were to log into Portainer, for example, and check the logs, you would see them being updated rapidly with all of the requests that are going to be going through our traffic container. So it's looking line by line, each line, for those indicators of compromise, and it's sending those off to the local API, which is a separate service that's running. Now, the local API has kind of two sources. It has the crowdsource based knowledge, i.e. that is the database that is continually being updated by everybody that runs Crowdsec. And there's also separate bouncers which are established, which are specific scenarios for specific applications. For example, there might be specific things for Home Assistant that we want to introduce so that it can really hone in on specific attacks that might be mounted against Home Assistant that wouldn't be seen elsewhere, or specific tolerances, etc., that are perhaps akin to an attack on Home Assistant as opposed to something else, i.e. you might have different tolerances for a web service compared to Home Assistant. When it detects one of those, it sends it off to the API, and the API makes a decision. And you can specify whatever you want that decision to be. The default behavior is to ban the IP address that the request is coming from for 4 hours. That means if an IP address is trying to do something malicious, it's going to get banned for 4 hours, and it should stop it in its tracks. The beauty of it as well is that you can set up real-time alerting. So I integrate mine into Gotify, which is a notify system written in Go, you might have guessed. And I'll cover that in a later video because Gotify is a great way to get notifications for many of your containers, many of your scripts, etc. It's highly customizable. So with introducing Crowdsec, we're adding another layer of security into our network, and hopefully again further reducing the likelihood of one of our containers being compromised, specifically things that are exposed to the internet. But importantly, Crowdsec works on anything that goes through the proxy. And as we know in our previous video where we deployed Pi-hole, we can now route internally local DNSs through the proxy. And also that means that those IP addresses are checked against the database. Now that's also good because if you had a piece of malware on your local network, for example, on a trusted device, etc., hopefully it should detect that if it's trying to do anything malicious and block it. So that means now we will have protection through Cloudflare, and I'll do a video on that later about how you can turn on some of the Cloudflare proxies and what that does. We should then have another layer of protection with our Sophos XG. Again, it has multiple attributes, sort of layer 3 protection, layer 7 protection, a known database as well that it's scanning against and checking traffic and signatures. We then have Crowdsec now built into the proxy, which again is doing another real-time check of what's actually happening onto our proxy. So in order to get to that Nginx container that we spun up earlier, you would have to go through all of those layers of security before you reach the container. And then we have some constraints around the container itself. We might want to put it on its own VLAN. We can opt to have no new security permissions on that. So if it was breached, it shouldn't be able to escalate privilege, etc. Now, luckily for us, the Docker installation is pretty straightforward. It's a little less complicated than the Kubernetes install, but even that is not too taxing. So within the config file, you can see, much like with our Pi-hole deployment, we have two services. We have Crowdsec itself, and we have something called a bouncer. What's a bouncer? Well, a bit like those annoying people that stop you trying to get into a nightclub. The bouncer is basically what handles the request in this sense, and in a Docker install actually contains the agents. And the bouncer is the bit that says, right, you can either come in and access this service, or actually, no, I suspect that you're malicious, or you are directly being malicious, i.e. we've detected a bad signature, and it prevents you coming in. As I mentioned before, Crowdsec requires 4 volume mounts. It requires an acquisition file. It requires a database. So this is its own database, i.e. this is a record of all of the bands it has dished out whilst online. So what's really handy with Crowdsec is not only does it have an online dashboard that you can create an account for and log in and see all of your alerts, it also has an internal dashboard that you can use. But as well as that, it also has a command line interface where you can quickly query all of the decisions, those are the bans, the decisions it's made, to see what active bans are in place. You can see which IP is banned, the reason for the ban, and the duration of the ban. And you can even customize that further to do a whole host of other things. Just check out the documentation. Obviously, as this is going to be integrated with traffic, it needs to be on our proxy network. So we need to specify that. For security, we're going to specify no new privileges true. That helps to reduce the impact of a container being compromised, i.e. if it's compromised, it shouldn't be able to escalate its privilege. For the bouncer, there's a great container. I'm going to ruin this name, but Fabonalaire has created a great container for encompassing all of the different parts, i.e. the agents, etc., all into a neat Docker container. Now again, this has some requirements. You need to plug in here your Crowdsec API key. Again, this is going to have to be on that proxy network because it's tied into the proxy. It needs to be able to communicate. And also, it depends on Crowdsec. So only run this container if Crowdsec is up and running. And again, we're going to specify the no new privileges. Now that I've given you a walkthrough of the Docker Compose files, we're going to need to make a number of changes to some of the config files. So we're going to need to change some files that are to do with traffic, namely its config file. We need to specify that we want to forward some of the traffic, well, all of the traffic to the bouncer. We also need to change the acquisition file to tell it which types of files, in this case the traffic logs, that we're going to send to it. We also need to change the bouncer config itself. We also need to add a middleware to traffic. Now, middlewares are pretty much what it says. They sit in the middle and they do something specific with the traffic. In this case, it's going to route that traffic to Crowdsec. Once we have those in place, we can actually begin the Crowdsec container, and then we can log into the Crowdsec container to generate our API keys for the bouncer. And once we have that, we should have everything configured to have Crowdsec operational. So let's go ahead and look at those config files now, and I'll walk you through the changes that need to be made. So the first thing we need to do is change the acquisition YAML file, and we need to add the traffic logs to that file. Once we've done that, we need to go into the traffic YAML file. So we're editing the existing traffic proxy that we have. And in there, we're going to add the middlewares for the bouncers. So that means anything coming in on those ports will be sent to our bouncers. Now I've included all of the config files you need onto my GitHub, so you can copy and paste and change those values to fit your setup. Okay, so the first thing we need to do is to change our traffic deployment. The previous version we deployed didn't specify logs. Remember, Crowdsec uses those logs, parses them to look for things that look suspicious. So let's add those now. It's as simple as specifying log, and we're telling it we need the info level. There are different levels, we don't need to worry about those. And we're telling it exactly where we want to store those. Now, within our Docker Compose file, we've mounted that location to our Docker host. I think it's /docker/traffic/logs. And we want to put in there the generic log and the access log. So when you've added that, you need to go and hit save. And then you need to go to your terminal and you need to restart your traffic container. So that's sudo docker restart traffic. So with traffic restarted, let's go and validate that we now have logs. And there you go. You can see that we have both of those files created. Excellent. Those are the two prerequisites that we need to make Crowdsec work. So let's get on to the next stage. Now we need to deploy Crowdsec. So let's navigate to our Crowdsec folder and let's deploy that container. And we can see that both of those containers have started. So let's just check our logs. We can see that Crowdsec has started, and we can see importantly that it has found both of the logs that we specified. Excellent. We can see that the bouncer has also started without any errors. But remember, we haven't registered the bouncer yet with Crowdsec. So that means that the bouncer cannot access the API. So let's go ahead and fix that. So to fix that, it's really simple. We have to run the command sudo docker exec. Now this is the first time we've used that command, but execs is short for execute. So what we're saying is we want to execute a command in the container called Crowdsec. And that command is cscli, that stands for Crowdsec command line interface. We want to say bouncers add, and then we're going to call it bouncer traffic. So let's hit return. So what that did is it went into the container, it ran the command, and it spat out the API key that we now need to add to our Crowdsec Docker Compose file. So let's copy that and then go back to our Docker Compose file and simply add this where the API key goes. Now save that. Go back to your terminal and let's redeploy our Crowdsec. Now because you've changed the Docker Compose file, Docker will know to rebuild that container. So you'll see there, Crowdsec maintained running wasn't changed because we didn't make any configuration changes. However, bouncer traffic says started. That's because it recreated it, it restarted it because we put in a new parameter. So let's go and check that in the logs. Everything looks fine in there. And now we're on to the final piece of the puzzle. We need to go back to our traffic config.yaml and we need to add a middleware in there called Crowdsec Bouncer. And we're going to give it the forward auth address of our traffic bouncer container. So let's do that now. So let's save that. Now the interesting thing is with Docker is this address here, bouncer traffic, is known to Docker because it keeps a list of all the DNS entries of the container in itself. So you can reference, much like we did with the Pi-hole installation, you can reference the name of a container and it will know its internal IP address. Finally, we need to make sure that we add our new middlewares to both of our entry points within our traffic.yaml file. Once that's done, you need to restart traffic again. So now that we have all that added, we've restarted all of our containers, we've checked the logs, we've got no errors. Crowdsec's working. But wait, that's a bold assumption. Let's test it. So here I have my home page working with the SSL certs that we gained through traffic. Everything looks fine. Let's ban myself and see what happens. So to do that, we go into our terminal and we type the following command. Again, it's a sudo docker execute. We're going to run this within the container. And we're going to add decision. So I mentioned everything that is done in here is called a decision. And we're going to add this IP address. Now this is my IP address that I'm recording this video on. You will need to put in your IP address, probably the one that you're administrating your Proxmox node from. So put your IP address in there and hit return. It came back and said the decision was successfully added. Let's check that within Portainer. And here you can see in the log a manual ban from localhost by IP, and again there's that default 4-hour decision. So let's see what happens now when I navigate back to that same page and refresh. There we have it. Access to Jim's garage was denied. Perfect. That means that although we've artificially added this, it shows that Crowdsec is able to make decisions and ban IP addresses based upon bad behaviors or manual blocks. So now, if we go back to our terminal, we can actually check what active decisions are being made, i.e. which IP addresses are currently blocked. And that's as simple as typing sudo docker exec crowdsec csli decisions list, and that will list all the current bans that are in effect. And as you can see, there's the ban that we manually assigned, and it's still valid for another 3 hours and 57 minutes. So let's go and unban myself, and then we'll see what happens. And there we go. Simple as that. So with Crowdsec in place, we've now added another layer of security to our network, and this will benefit any container that is routed through traffic. That's right, I'm talking things like Plex, Jellyfin, Pi-hole, anything where you're routing it through your traffic, which also has those SSL certificates. Excellent. One last thing you're going to want to go and check out are collections, and as I mentioned previously, these are bespoke rules that are tweaked towards certain applications. So for example, there's one for Home Assistant that you should deploy if you're exposing Home Assistant to the web. Okay guys, that's a wrap. I'll catch you on the next video.